Hello guys, so today we will solve one of the most popular questions in Leetcode called two-sum. We'll start by analyzing the problem statement, input-output, using a checklist, just basically a set of questions that you can use to solve any data structure and algorithms interview question. The link to the complete checklist is in video description. During the interview, I mentally go through the checklist, and as you solve more problems, that process will become faster. Well, let's start. We see that in the description in the problem statement, we are given an array of integers called nums, and also we are given an integer called target. That is basically our input. So it's pretty straightforward. We have an array and just an integer. For the output, we are trying to get indices of two numbers that add up to the target. Target, as I said, is given by the input. So that's our output. Um, Furthermore, we have the clarification that there's exactly one solution, and that we may not use the same element twice. Second part is kind of tricky and might be a good question. First, good question to your interviewer, because it means basically that you can use the same value. Like for example, in example 3, we have two trees that add up to 6, but they are different indices, which basically means they are two different elements of the array. Now let's go to that basically covers the input and the output. Now we can go through the first example. We see that we have like 2, 7, which immediately add up to the target 9. So we can return the first numbers and the first indices, which is 0 and 1. Now, next we have the second example. And in the second example, we have 2 and 4, which are 6. And two indices, we have our 1 and 2 arrays, 0 indexed. So 2 is at the index 1, 4 is at index 2. Now we can move to as we covered all the examples, we can move to the constraints part of the problem, which during the interview should explicitly ask the interviewer what's the nature of the input. As you can see, the number select or the array of the length of the array is 2. So it doesn't make sense to have an input that only contains one number. You can see that also we don't have any wild ranges for nums, the elements of array, and also the target. And there's only one valid answer. There's also a hint for the brute force time complexity, which is n squared. And if we move to the special cases where we have only two numbers, that's not really interesting to us because we just basically check if they add up to the target. But if we increase the size of our array to 3, as shown in example 2, we will see the nature of the brute force solution. We will be checking first number with the second number and the third number to see if they add up. But then for the second number and second ratio, we wouldn't be checking again with the first number. We will be only checking the second and the third number, which basically means that we have two for loops that one goes from the beginning of array to the end of the array, and the second one is dependent on the first loop, and basically goes just starts one place after the first loop starts. So that's our n squared solution in terms of time complexity. Now we think about how can we improve this, and if you go through the checklist, we can think, can we sort the array? Does it make sense to sort it? Well, if we sort it, we will have n log n time complexity, which is good, but we can try to reduce it to all in our time complexity. That's our goal. And we don't have a way to split the numbers into two halves and then operate on each of the halves and combine them into the solution. We can, but it would be a standard concurrent divide algorithm, leading to a complexity higher than linear. That program would be an overkill too for this problem. The thing that you are looking is actually effectively searching for a number, and effectively searching for a number, the person should be a hash map. Now let's go through a real example just to see how the iterations behave, how differentiated things change, how the hash map values are getting inserted, and how the algorithm basically works. So in this example, we have an array of 5 elements, and the target is 8, and we start our iteration from in 0 at the element 1. The square bracket is I guess the mark for our hash map, and we will be putting the key value maps there. So for 1, we basically are searching for 7, but that up to that add up to 1, it adds up to 8. So that's our interest. When we get to the number 1, we try to search for number 7 inside our hash map. And if it exists, then we know that there is those two indices make up to the when summed up, they make up to the desired target. Actually, when we did iteration to the like just a regular for loop, we remove the index to the next element, which is 5, and we basically check for number 3 that's inside the if it's inside the hash map. So for the hash map, we have to declare the key and the value. For the key, we can use the element, the array element. And once you find its pair, what do we want to remember? We want to remember the actual index of that element, because we want to return the current index of the current element, and the index of the element that, when added up to the current element, adds up to the target, the desired target. So once we hit 3, we are searching for 5, and we have a hit inside the cache. The 5 is inside the cache. We have that key, and we can return its index, which is just basically the value inside the hash map, connected map to that key. And so we can return basically the current index, which is 3, and the value of this map to the key, which in this case is 1. And that's basically our desired output. The time complexity is linear because we just loop once for the array, the input array. And for space complexity, we have a hash map. And in the worst case scenario, we can place almost all like n-1 elements or n elements. If by problem statements, we are not guaranteed that we have a solution. So the space complexity is linear too. Now back to the solution. First, we will declare a map. And we are using Java. We're going to declare a map that's mapping an integer to an integer, which in our case will be just the element and its index. Then we will go and declare a for loop that starts from at the beginning of the array and goes all the way to the end. For each of the current elements, we will check if we have the number that added up to that element adds up to the target. And we can easily check by just subtracting the correct number from the target. If that's the case, we will just return the index of that element that we saw previously in the array, which we do by using our hash map. And if not, we will just basically put the current element value and the index inside the hash. Let's not let the compiler scream at us. We will have the default 0, index as return value, which will never be executed. Set by prop statement. We always have a valid solution.